Hello everyone, this is Jay at Inspiration Masters. As a part of our inspiring series, we get the opportunity to meet the difference makers, the entrepreneurs, the artists, the business owners who are making a difference not just in the United States but around the globe. And today I have two difference makers here with me. And inviting here with me is Mahesh Nandyala. Mahesh, welcome to Inspiration Masters.
Thank you so much.
And Srilatha Nandyala. Srilatha, welcome to Inspiration
Thank
Masters.
you so much.
So Mahesh and Srilatha, they have a special company. It's called S3M Solutions, which is a global leader in the drone technology. And we'll be talking to them a whole lot about drones. They have executed about 80 projects across 14 verticals. Both Mahesh and Srilatha hold their degrees in B.Tech from the Jawaharlal Nehru Technology University. And I'm really excited about the technology which they have used and successfully put around the globe. And we're going to hear a lot about the drone technology today. So let's start. Let's dive into, because
Sure.
we're so excited about the drones, and we hear all these things, and the kids are hearing, and they watch this, the packages like Amazon package dropped at your door, the
Exactly.
drones and all those things, but we don't know much about the technology. So tell us something about how you got the idea. Like, how did you come up with this idea? All of a sudden one day the drone hit and said, "Oh, I need to make one." How did you get the idea?
It all started about 4 years ago when we were actually talking to a couple of customers on using drones for agriculture use. We started using, it all started there, and it was like an explosion. We started looking at various other opportunities that it could create, various areas where it could reduce cost, increase safety, increase efficiency. We started off with just the agriculture vertical and then quickly expanded over others because it made value for the customers and the ROI was very quick. So that made us get into drones.
Wow, that's interesting. So did you see a drone before? Like when you were in the school, did you see any drone? There were no drones?
No
out there to
drones,
see,
no
yeah.
drones
The
there.
only time we knew about drones was when my kid was actually telling, I want to play with a drone. Until then we were like, what are these drones?
So you researched on it, but now you have a very large setup for the drones.
Yes.
So what are the different things which you have come up, and what is it that you are working on? So I will be wanting to know what kind of drones you make or use and things about it.
So the drones are broadly classified to be either multi-rotors or fixed wings. So we have the design and engineering capabilities to manufacture these two different kinds of drones, and we use different kinds of materials. Like we make our drones using foam or wood or composite material, or also Kevlar. So we have, as of now, manufactured 14 different kinds of drones, and each drone is unique with...
Wow, 14 different kinds
yes,
of drones.
Yes.
So
you
it
have,
depends on the various requirements of the customers.
wow.
So these drones, they have different endurance and payload capacities as well. And each customer has got a unique requirement.
That's
and
right.
To cater to those requirements, we customize the drone and we use it. And I would like to quote a very good example here. Wherein one of our customers, he had a problem statement that he had to measure the ambient air quality.
Okay.
And to do that, he was using a traditional method wherein he was installing the sensors at different altitudes.
Okay.
And he was measuring the the quality of air at each
Right.
altitude. That is a very tedious and a very difficult
Tough thing,
process.
because
Yes.
you have to create towers or something,
Yes.
and you
Yes.
measure it constantly,
Yes.
right?
And
Exactly.
also, if you have to measure different kinds of particulate matter or CO or
Pollutants.
different kinds of pollutants, you require different sensors, and these sensors have to be installed at different altitudes, which increases the overhead cost. And
Right.
again, maintaining them, a person has to manually, take the ladder or whatever, and he
It's-
has to do the changes.
Yeah,
and
that
stuff.
would be tedious, yeah.
Yes, yes. So we came up, we did a lot of R&D on this, and we had to revisit our drawing board several times
A
to...
lot of sleepless nights.
Yes. So we did a lot of R&D on this because we came up with, in embedding all these, we came up with
Sensors.
12 sensors, and we thought of embedding them into a small kit, and we mounted that kit on the drone, and we flew the drone vertically, and also not only vertically, we also did it horizontally, so that we measure from the spot where the customer actually wanted how far are the pollutants affecting the air quality. So we did it even laterally and horizontally, and for that we had so many challenges because when the drone was actually creating the thrust, the air beside the drone actually moves away.
Right.
That actually makes a lot of changes when you are measuring the
air quality,
pollutant.
True.
So it should not disturb it. So we had to make so many kinds of designs, and we had to do probably more than 300 flights or even more to just check one sensor,
Right.
and when we add another sensor, how is that affecting the other sensors
Calibrations
work?
and all that.
We had to do a
Wow.
lot of calibrations again and again, revisiting the board, and now we are really happy that the traditional methods, by using the traditional methods, the kind of picture that they get, we are able to give around 98% of accuracy with our drones.
Wow.
And we are also able to make the three-dimensional isoline heat maps for the pollutants as of now.
Wow, very interesting. And Srilatha is the Chief Technology Officer for the S3M. So what we are going to hear is probably intrigue a lot of young people out there to see that this is something which is way deeper. It isn't just the flying drones which you buy off the shelf from Best Buy or Fry's Electronics. It is something which is going to take us a deep dive. And I think it was so intriguing to me that you and I like the go in detail and describe. You want to know all about it. So
I
that is-
really need
that's
to
just-
thank my team for this, because my team, they are very dedicated, and we are not happy with the result, even though we get it right. They tell, no, we have to do one more try, and that's the passion that we like about
that's something
that.
which is sticking.
That's pushing
making
us
better.
beyond.
Yes,
Absolutely,
yes.
and
Yeah.
that's the way to go. And so this is one usage, but you are using across so many
Yes,
verticals.
we can go on and on with the use cases because
We'll talk about it in a bit.
Yeah.
Yes,
yeah.
yes. Tell me something else about what kind of payloads you use and what are the other kinds of drones and things you do.
Sure. The payloads, we have drones that are customized that can carry a payload of 2 pounds all the way up to 20 pounds. The payloads are different sensors that we use, as she talked about, sensors to monitor the air quality. Payload like a 30x optical zoom camera for first responders or police or something like that.
Right.
We also use thermal cameras for inspection of power lines, heat signatures,
Right.
the roof or the energy loss in a building, a commercial building or something like that. Then we also have the technology to carry a LiDAR camera to do much detailed inspections. So we have used payloads, sometimes we've used speaker phones as payloads. To do some police negotiations,
Right.
or to announce in some of the underdeveloped or developing worlds where we've used drones to announce and publicly create interest. So some of the other payload that we have used is a speakerphone, a megaphone attached to a drone for some customers to generate interest or to identify and talk to on police negotiations. And for one of the customer, we have used drones in the developing worlds where we have used drones as a medium to engage with citizens and talk to them and showcase the importance of segregating wet waste versus dry waste. So there are a lot of payloads that we use, and we customize the payloads on the need. We also...
the interesting thing about using it to spray for malaria.
Oh yeah,
Yes.
we've used drones to eradicate the next generation of mosquitoes, where we've used drones to spray larvicide using drones, and that's a very good use case, and that's a different payload altogether. So we carried about close to about 20 liters of larvicide and sprayed it in inaccessible areas where mosquitoes breed and the next generation of larvae grows.
Oh, that is very interesting, because there are places where people cannot go in and spray.
Exactly.
So that is really very interesting.
We later checked on the number of active larvicide that were still in the water, and
it
was considerably less,
Uh-huh.
and that was really effective.
Wow. So I mean, so there are so many usage. It's just we scratching the surface kind of thing.
Exactly.
That's what it looks to me, right? And you said you go across several verticals. So tell us something about that.
Drones can be used in probably any field or any vertical, but we have been very successful in using it in about 15 to 16 different verticals where we have use case and business case established. We have been extensively working on railways, where it has a very important value proposition and increasing the safety of rail tracks. We have done.
So what I understand by that is that the drone is going and checking the tracks before the train goes in.
Exactly.
And making sure that the track is in a good shape,
for the train
to go in. Very interesting.
We have used drones in agriculture, where we have identified pest infestation before it actually affects the crop. We have a tool where we analyze crop yield, where we are able to predict the crop yield, which the farmer cannot do it with a normal eye, or what they're not able to really assess the crop loss as well as the crop yield. So we analyze that using special cameras on the drones. We have artificial intelligence platforms where we are able to analyze and increase the yield at least by 20 to 40%.
Wow.
So if there is any bacterial or fungal infection that is on the plant, and the plant gets infested by it, and you cannot detect it at the early stage with a naked eye.
Right.
You can still do that using the drone imagery. When we capture it, we can detect the crop health almost close to 10 days in advance to the infestation.
That helps us all, because that helps to remedy it.
Yes,
You can
exactly.
do the sprays and whatever.
Lesser, pesticide to be sprayed as well. So.
Yeah,
And that's a very important point. The inputs that are given to the farm, like the pesticide or the insecticide that's being sprayed, today is being sprayed all across uniformly in the entire farm field.
Right.
Suppose you have a 500 acres of farm, and you're talking about spraying the inputs across the entire farm, which is wasting the inputs or the fertilizers and all that. So we pinpoint the geotag location where this is needed, and then we spray it using our drones at the exact location where it is needed, and that also helps in increasing the yield.
Both ways, right? Increasing the yield and
reducing costs.
One of the major concern is the pesticides.
Excessive usage.
Excessive usage
is a big,
that can be
problem.
reduced.
And even soil and loss of topsoil because of the excessive usage.
So it's a multitude of usages. Even if you consider only one application, then there's still a lot of positive things coming out of that.
Yes.
We also use drones heavily in energy. In energy sector, we use it in solar farms, we use it in wind farms, we use it in oil and gas. We also are able to identify anomaly in the power lines. That's a very huge use case. In the power lines, due to the resistance change, there's a lot of transmission losses that happen. So we are able to identify, pinpoint to the customer where this loss is happening and why this loss is happening. If they're able to look at that and then make corrective changes, that will get them to save energy.
I think it's worth spending, looks like, because when you can save so much.
Yes.
Because if the transmission loss is prevented, that means that's cash.
Exactly.
It's a simple thing.
Not
simple
only
math.
on the cost, but also on the time.
Yes, on the time too.
Yes.
Yes, that is true. And you have to produce more when you lose on the transmission.
Yes.
That means it costs more.
And even the sag analysis, we do the sag analysis of the poles and the wires. We identify the angle between pole to pole. So an entire gamut of operations around energy. Apart from that, we also use drones in mining, where we understand the extent of mine excavated, the stockpile analysis, the volumetric analysis. We've used drones in urban planning, where we create digital twins as accurate as 8 millimeter accurate. Three-dimensional digital twins, three-dimensional terrain models, contour models in building a new city or in existing city. We have done flood modeling and flood models where you're able to analyze when a flood hits, how is the water going or how is the water penetrating, where does it affect.
Right. But that's not practically possible to go and do it. Only drones can do that.
Exactly.
Part, yeah.
So
and also about the silt monitoring that
that's a very unique use case where a reservoir that carries water, the capacity of the reservoir considerably depletes over time. That's because of silt being deposited under the water.
That's right, yeah.
So with drone imagery, we are able to accurately identify the silt underwater.
Right.
So the cleaning process becomes very easy, and that's a very unique use case where we have used drones.
Excellent.
So a lot of use cases, a lot of interesting applications.
The most, the another interesting application where we were able to identify the cannabis.
Oh yeah, there was a department within a government which wanted to, where cannabis is illegal, they wanted to identify cannabis cultivation and growth. We were able to do that using our hyperspectral cameras. So back to other question about payloads, hyperspectral cameras, multispectral cameras, all these are part of the payloads that we use. So
wonderful. So that is so intriguing. I think you've interested so many young people out there starting to think about this thing, and I'm really, really interested in knowing more about this. And you mentioned that you're using AI for the drone imagery. Tell us something more about that. Because the AI it's not just a buzzword, that's the future. And drone is the future. You're putting both together.
Yes.
So tell us something about it.
So we are using the artificial intelligence, the latest technology as of now, the buzzword that's going on. We use it to detect the anomalies in various verticals that we are speaking as of now. Because we have completed successfully, we have done around 80 plus engagements and we have collected a huge data. And we continuously feed this artificial engine with all the data sets that we have, and our team is really dedicated and really hardworking in this aspect, wherein they continuously, each image, they take that as a valuable possession and they, analyze it and train the system so well that with our mission vision data and all with all the accuracy that we can boast of as of now, I really thank my team for all their hard work. So in all these 14 or 15 different verticals that we are doing now, we feed the data continuously to the system, and we are able to get around 95% accuracy with the anomalies detection.
Wow.
So for example, we had for the railways project that we did, we are able to understand the angle of curvature with our system, and we are able to detect different other things like missing dampers, missing bolts, missing nuts, and the right of way for the vegetation influx, because there are so many trees around, and when they fall, so even that accounts, and there can be power lines that are sagging and in the way of the tracks. Yes.
Yeah.
So
Wow.
we are able to detect all this with the data that we have been constantly feeding our system into.
I think that's amazing part of safety, because those things are practically not possible. I mean, somebody has to go and look for it.
The traditional thing is that the lineman going.
The lineman going, that's
and
right.
Human error always is
Is always
a
there.
possibility.
Plus, I think it's what drones can see possibly is when you say nuts and bolts, That is not even humanly possible.
Yes.
That's
Yes.
very difficult to detect on a track.
We are able to
Yes.
Manually,
identify.
it's very difficult to do it.
So, there's an interesting thing here that I want to tell you. One of our customers was really unhappy with the results that we provided because he was very sure because the line was laid very recently, and he challenged us that there was no crack on the line, wherein we detected that there was a crack.
There was a sleeper damage that
Yes.
was detected in a newly laid line, railway track. The parallelity between tracks, the curvature of track, and she was talking about the sleeper damage. There was a sleeper damage, and the artificial intelligence engine caught that. We zoomed in to see whether that was right, but we didn't find anything in the drone imagery. But my artificial intelligence engine says that there's a anomaly at that particular sleeper.
Right.
So the engineers there, we did a field survey. We all, the engineering team and our team from the customer side and our side went together to that geotag point, and we identified that the AI tool was right. And
Right.
there was
There was
some
a problem.
damage.
There was a problem, yes.
So what happens is it's still evolving. The market
Yeah.
is still evolving. We are learning. We're learning from new
Yes.
challenges out of the box,
Yes.
ideas out of the box, problem statements given.
Yeah.
The AI tool, it's not really rocket science to build a AI platform, but to make it accurate, it
Yeah.
needs to be trained with a lot of data set.
That's right. Yeah. because
That's where
what do you
the,
call it, 1 billion data points to
Yes.
start with.
Exactly.
Right?
So
So
there was
that's-
another customer who actually wanted to lay his solar farm. And to do that, he wanted because you know how difficult it is to lay the
250
solar farm. You
megawatt,
should it should be precise, and elevation difference here and there
Right.
causes a lot of loss.
Yes.
So were doing the DTM and DEM, and as he was talking, we were doing the digital twin for all the area, and we gave them the results, and they had it out in some of the locations because they just did the laying out of the place and all that. So they went along with their field engineers and they did a manual mapping for the
Recheck
area.
of what we did.
Yes, and it is even to our surprise that we were at 8 mm accuracy, and he was mentioning in one of the discussions that that is how we actually rechecked
Right.
with the traditional methods as well, that
That's
we
right.
came to an 8 mm accuracy.
That is right, because if it's a growing field, it's a new field, you need all the rechecks to
Correct.
see that
Yes,
data.
Exactly.
yes, yes.
And we were able to save time. What we
Absolutely.
did in like 15 days with using drones and the technology that we have was actually to be accomplished in about 3 months. So we're cutting on huge time.
That's a lot of money.
Yeah, that's a lot of
Yes.
money.
Cash.
So, yeah.
Yeah.
Very interesting.
And even on the power lines, that is like a really challenging task as well, because when it comes to the high transmission lines, and the traditional method is that they are using helicopters, and that is a lot of expenditure.
That's right,
And-
because you have to have a human behind it.
Yes.
That's the biggest one.
Yes, and also there is, because of the high transmission, and if they have to get a closer image,
Yeah, they're not able to get
they
a closer
actually
look.
fly a little close,
It's-
and
it's high
there
risk
is
to
a
do a
high
helicopter
risk to
close,
the blades
right.
getting tangled, and there are huge chances. And when it comes to the local distribution lines, the lineman has to manually climb using the
okay.
ladder and check all the lines and stuff. So now that we are using drones, we are able to manage, but our team is really careful on that point, because
We
because
have a lot of
the-
checks,
yes,
standard operating procedure, where we have a lot of safety norms we adhere to. We exceed the safety parameters prescribed by the Federal Aviation Authority. As a matter of practice, we ensure that all our drones have an ADS-B out. What that means is we are able to identify manned air traffic.
Okay.
That we are not colliding, or we are not going in the altitude where
Right.
a airplane, passenger or cargo or a helicopter is flying.
Right.
So we have parachutes for emergency landing of our drones. And we have this as a standard practice on all the operations that we do. Maybe
Right.
a very small operation or a very big project or an engagement. So that's one of the factors that we consider.
Right.
Coming back to the safety, we also exceed the safety in terms of providing pilots with excessive training.
Right.
So we have a lot of checklists, a pre-flight checklist, post-flight checklist, during flight checklist, after flight checklist, and then we have safety manuals for all of our drones.
So these are not autonomous; they are pilot drones.
So we have autonomous drones as well. So that's a very good question.
Because so far we had understanding that okay, these are things are flying by themselves and finding out the ways, but these are pilot ones, so there are highly trained pilots behind them.
Exactly.
Yeah.
So we have autonomous drones that can fly and do a mission from one point to another, and then complete their mission and come back home.
Right.
But as a matter of safety, we ensure that there's a pilot who just has the remote ground control station, and who can take control of the drone in case of an emergency.
That's right. Just like the current Teslas.
Exactly.
So using the ground control station, they can monitor everything, like the altitude at which it's flying, what's the remaining energy in the drone, whether it would be able to come back to the destination, and what is the speed at which it's going. You can measure all the. Yes.
I like the idea. I did not know about that, but that the drones carry parachutes to land themselves safely, because otherwise there will be loss of a drone.
Exactly.
So that's interesting.
So we make, as she was pointing out, we make drones using foam. That's just because to keep it light and the shape and structure, the aerodynamics. That's all where we do a lot of research in terms of selecting what material has to go where, and the design. We use CATIA for our design, and we have design engineers who design the drones, and we rigorously test them. We do a stress test, we do a drop test, we do what if one motor fails, what if two of them fail, when does the parachute deploy automatically, all that entire.
So that's all interesting things which I think we might have to continue that part, and I'll have to call you back again specifically for the manufacturing of the drones, because we want a lot of our kids to be interested, and a lot of young people out there interested in that drone technology.
That's really important that we ensure that our kids are actively engaged into discussions like this, because this is the future and this is what they need to learn.
Exactly. So tell us something about the vision for the company, as well as I want also to know about the technology, the drone technology is the future, both of those things.
Awesome. So the drone technology future is is amazing because of the number of use cases where it can be used, the applications that it has is multitude.
Yes.
That said, what I anticipate in the near future is we'll be looking at connected drones.
Right.
That's what I'm speaking in Amsterdam in December. In a World Drone Conference, where we're talking about drones talking to each other, and we have a centralized hub of drone. Think of it as a CPU,
right?
Where you have one centralized drone which gives instructions to multitude of drones around.
Right.
So that's going to be the future, and that's going to save a lot of time, cost, and even more. Getting into drones, so connected drones is the future.
That is a future.
Yeah, and for the vision of our company, we want to expand and get into newer areas, challenging areas, out of the box use cases, and that's where we want to get. That's our vision and that's our passion.
That is awesome. So we learned so many things about the drones today. A whole lot of things were totally new. You got me to some technology points too. So I'm thinking about, okay, maybe I might have to do some research to find out more about it. So again, on behalf of the entire team of Inspiration Masters, I thank you both for coming. Thank you, Mahesh.
Thank you so much.
And thank you, Srilatha.
Thank you
so much for giving that great information. And on behalf of the team, I wish you all the best with all you undertake. So before you go, I still have one more question for you. And that is regarding the humanitarian use which we are focusing on.
Oh, yes.
And you're working with the international organizations.
Yes.
Tell us something about that.
We are now actively engaged with the United Nations, where we want to use drones for humanitarian cause. People in Africa are suffering with snake bites, and the antidote to reach them is taking like 12 to 14 hours. By the time it reaches, the patient is dead.
Oh.
So that's where we want to change the paradigm, and we're looking at carrying about 7 kilograms of payload,
Uh-huh.
maybe vaccines, maybe blood, or maybe important medicines.
Uh-huh.
And we have been invited by United Nations, UNICEF, to come to
Uh-huh.
Malawi in
Right.
Africa
Uh-huh.
to test our drones if they could create an impact.
Mhm.
We're also talking to World Bank
Mhm.
in using drones for humanitarian cause, and that's going to be the next major step or the next major action item for us in terms of the company.
Right.
And we are also planning to run campaigns because in these countries HIV is more prominent,
Uh-huh.
and they do not know how to prevent it.
Okay.
Cholera,
So,
HIV,
yes.
malaria,
Mhm.
all these using drones. We want to educate the children and the people there
Right.
in their local language.
Right.
So you would be seeing drones carrying banners,
Okay.
talking to them.
Just as we see the helicopters.
Exactly.
Yes, yes.
Right.
Since we
Very
already
interesting.
did the use case of having a speaker on the
Wow.
drone and educating people on wet waste and dry waste,
Mhm.
so we thought we would use the similar kind of awareness campaign even in Africa, using their local language so that they know how to prevent and
The steps that need to be taken to
Yes.
eradicate and reduce.
Right.
So
Awesome. That's awesome. That's amazing. Again, Mahesh, Srilatha, thank you so much for giving us such great information about the drones. And everyone out there watching, we learned so many things, right from the power lines to the railway lines to all of the major installations. It could be wind power or the solar power, things like that. And mainly the humanitarian causes which you're doing, which is an amazing job to work with the UN and UNICEF. So again, thank you so much for sharing all that information. And on behalf of the entire team of Inspiration Masters, thank you so much for coming, and I
Thank
wish
you
you
for
all the
having us
best
here.
for all the
Thank you
things
so
you
much.
undertake. And wish you all the success for the new undertaking which you are taking all over the world.
thank you.
Thank
Thank
you.
you so much. Again, thank you for watching. This is Jay at Inspiration Masters. We got some great information today. I hope you enjoyed it, and subscribe to the YouTube channel so you do not miss any of these interesting interviews here. And also you can subscribe to the Facebook or like us on Facebook. You might not miss any of these interviews. Thank you for watching, and I will see you soon.